I'm continuing the thing that I started yesterday, and that was basically working with delegated GitHub agents in the background. And I would say that now I have a lot more experience with it than yesterday. Yesterday I was just starting out. Today I was able to complete like 30 pull requests. Not all of them are merged, but I think 21 of them are merged, which is a high number. I think that I was never able in my life to come to Workday, start to learn something new like GitHub agents, and in the meantime, I would be able to complete 30 different bugs, or at least to learn something about these 30 bugs. That is just mind-blowing. But what you can do with agents that are running in the background. But basically, in this video, I want to tackle like some of the things that I noticed and some of the things that I think might help you adjust to these workers easily, or to just shift your mindset about this. And I would start right away from that. First topic is that yesterday when I was starting out with this, I felt that this is like an extension of vibe coding. And in a sense it is, because you are still vibe coding, you are still using agents to code. But I came to realize that actually the mindset shift is, I think, as big. The shift in the mindset is as big as the jump was from traditional to vibe coding and from vibe coding to parallel agents. And we all know that people got stuck in this transition, like they are keeping to this and like no vibe coding ever because this is, unpredictable and so on and so on. But as you get used to it, as you adjust to your expectations, how this system works, what are the success rates, what can be solved with vibe coding, what cannot be solved with vibe coding, you kind of get a sense of how to work with these systems. I would say the same thing applies for parallel agents. It's not just the smooth transition to vibe coding as I assumed, and I have several reasons why this is, and I think these reasons might help you to get the most joy out of switching to this. So just about control, like that's my first point. In the traditional coding sense, like you had full control. Every line, every byte is in your hand. In the vibe coding era, I would say that like you took a problem that was your special snowflake and you vibed it out and you managed the code and fixed, but you were still like fixated on that one issue. Now with parallel agents, when you are running 10 things in parallel, I think you need to switch your mindset to like this is not your special problem that you are solving. You are solving 10 problems at once, and you are shepherding this process of like looking over them. And this shift is basically coming from the same shift as when let's say system engineers switch from managing one server then to managing multiple servers and then to managing pods in Kubernetes, where like every pod is just a pod and there is nothing special about it, and you can easily recreate it, delete it, start again. So that is the mindset that you should take with parallel agents. You should take small bets and then see what sticks, and to run as much bets in the background as possible as you can manage to review and to assure that they are high quality. So the next thing is like synchronicity and asynchronicity. With vibe coding, you are still synchronous. Like you give it a task, you wait out, you see what happened, you see that the browser, like everything is there before you. Now with parallel agents, by default, everything is asynchronous. So you give it a task, you delegate it completely, and you need to prepare that, like the first thing that you give it and the context that you give it, that will be the result in, let's say, half an hour. You cannot do like half-assed first prompt and then, you will just fix it as you go, because those fixes might come, an hour later. So yeah, a very different shift in how you communicate with these things. I think that in the real world as well, the synchronous and asynchronous communication patterns are different, and the difference apply to this kind of coding as well. So the third thing is that with traditional coding, and I think vibe coding as well, as at least that was the experience for me, is that I would take one special thing that I'm going to solve. Like I look at the list of things that are in the backlog. I take the first one that makes sense, that aligns with our goals, that aligns with my daily schedule, and then I solve it. Now with parallel agents, you have to stop thinking like that. And I think the proper mindset to take here is start the day, just figure out what are the several problems or the class of problems that you could tackle today, and then just let them run in the background. I think that for me the most successful thing was that I take like 2 things that I really need to solve or I really want to deliver today, and also to kick off like 5 or 10 other unrelated small things that like some copy changes or some bugs or UI changes or anything small that can just run in the background, and in the afternoon I can just run through them and verify that they are good and then push to production. So I think that this was a big one for me. These previous 2, I don't know, these were kind of easy, but this is a bit hard. But yeah, I'm getting used to it. Now, when it comes to the mental model of the system, this is something I noticed about myself, is that while I was traditional coding, like I had a very strong mental model of the system. Like I knew how it was completely set up, and basically I'm in full control. Now with vibe coding, that was getting a bit out of hand. Like I still feel that I had a good control of the system, good understanding of it, but in vibe coding and especially here, I think we need to, as engineers, invest a lot of time into making sure that the mental model of the system is still in our head. We still understand what is going on. We didn't write the code, but we still understand every line. Like that should be a given. And then the last point is, like in every iteration we were optimizing for something. I would say that in traditional coding it was optimizing to make development simple, like simple to write code, simple to extend code, simple to write classes, and so on. With vibe coding, this shifted to, let's say, faster, because let's say it wasn't a problem to generate 500 lines of code. Maybe it was good, maybe not. So the iteration loop was around taking small bets, like let's try these 1,000 lines of code. Okay, it doesn't work. Let's try these other 1,000 lines of code, and you try out, let's say, 50 things, and one of them is just great. And with traditional coding, you weren't able to do that. You had to plan out what you were doing. With vibe coding, you are planning out how to test out various things fast to spot the successful thing. And with, let's say, parallel agents, I think what we really need to optimize for is review, to make the review cycle easy, because that is the blocking point. Like I can create and start off like 50 issues, but I need to review them. I need to understand them. I need to make sure that it works. Now that review cycle is let's say for Operator, it's not the best. So I need to pull out the new code. I need to restart the server, do some stuff. It takes maybe even 2 to 5 minutes just to get to completely working state where I can test out that code. I think we really need to drop that down to like several seconds, maybe 10 seconds. I can check out, restart everything, rebuild everything, and then just I can jump into the browser and test it out. So in this sense, I feel that several skills really do translate well to let's say parallel agents. Like one thing is, if you have a full stack understanding of your of the whole system, you can do lots. Like if you only have understanding of the front end or the back end or the infrastructure or the deployment, it gets you to some point, but it won't get you through the finish line. So having a full understanding of the whole code and the whole process really pays off. The second thing is to be able to break down bigger problems to smaller ones. That was the same thing in traditional coding. It just translates really well to parallel agents, because ideally you would give very small problems to these agents, and they get back to you with like very specific answers in, let's say, 5 to 10 minutes that you can very easily verify and then just ship to production. So breaking down big problems is still a good thing. Third thing is good writing skills, and I don't mean good writing skills in an emotional sense or fluff thing, but you need to be precise. You need to be to the point, to remove all the fluff, to remove all the bullshit, the jargon that is completely unnecessary for this issue, and then get down to the specifics. As much detail as you give to the agent, as specific you are increasing the likelihood of success. The rest are just async work. I think it really helps work delegation and QA. If you have good QA skills, this translates very, very well to this last step that is actually the biggest bottleneck right now. So that was point 1. So be prepared that you need to rethink how you develop code from the ground up. It's very exciting, but at the same time, it is a bit scary. But we are here to learn it. So the second thing was to basically comment about your expectation. And when I say comment about your expectation is, I know programmers that were really struggling from traditional to vibe code to adjust themselves from traditional coding to vibe coding. And I think the biggest reason was that they didn't get 100% success rate. And because LLMs are basically just statistical machines, you really cannot expect that. And when you go to parallel agents, this just multiplies and accumulates. So here is a very reasonable, very not reasonable, but an expected outcome of what will happen if you, let's say, start 10 issues at once. And you can look through these codes and you will verify that, this is it. Like it behaves just like this. So you can expect that the agent will just one-shot one problem. Like it will just completely understand what you wanted. It just give you the code back and you can ship it. It happens, but I think that it's a rare case, like 1 in a 10 situation that you will get this. The most situations that I get is like the code is almost there. I see problems, or I see coding standard problems, or something is just not right. And at that point, I can continue to prompt Copilot to run again, but I think that it didn't really work. So my approach there is to pull down that code and then continue with Cloud Code or Cursor or VS Code and just refine it a bit to get it to a shipping state. So usually this takes, when I have like everything ready and all the files are open and like everything is prepared, this to me takes like a 10 minutes per issue. I go through the code, I adjust the names of the variables, I adjust some, UI styling or small things. You ship it, CI gets you a green and you ship it. So again, this is like 2 out of 10. 3 out of 10. Like it is almost right, but there is lots of work to do. And at that point, it happened to me quite a lot yesterday. At that point, I think the best approach is to manually pull the code down, make the changes, unblock the AI, because it just cannot solve that problem. Like there is no way that it will solve it. You pull down the code, you manually adjust some things, which can take, from anywhere from 5 minutes to an hour, then push it back, and then continue with Copilot. Okay, now you got through this big problem. Now continue, finish it, add test, add everything else to make it shippable. So this was another set of issues, and I would say 3 out of 10 were just not good solutions. I encountered example where just the direction was wrong. Like it started to solve the problem. When you open the pull request, like that is probably not how you should solve a problem. I think I had a race condition in the code and it tried to do various stuff. Like that is definitely not the right direction to take. In these cases, I advise close the pull request, write down in the issue what was specifically the problem, like extend the context for further development, and then just leave it. The other thing was, let's say we had a pull request that is just basically a bad idea. You implement it, you open it in the locally, you try to test it out, and it feels stupid. Like why are we doing this? Maybe it was written down, several months ago. The idea is just plainly wrong when you look at it, and this happens. I think 1 out of 10 of these ideas are just plainly wrong. And the last one is like wrong implementation, but usually these are because you have limits about the architecture. And what I mean limits about the architecture, like some package is not installed right, or your deployment process is not capable of doing this, or you're missing some piece of infrastructure. Let's say you need Redis to be able to implement something, or you need something else. And if you just let the system the agent write it out, it will basically give you a bad implementation because it will try to re-implement that from scratch, which is obviously not a good idea. So be prepared for this. Now, to a traditional engineer, this might look scary because look at it, like I have 10 things and my success rate is, let's say, 1. But I would say that it's not 1. It's actually like definitely 6 out of 10. But I would say that it's even like 8 out of 10. Like only this last one is actually a bad thing. The rest is like I can still work with this. It saves me a lot of time. Wrong direction, completely valid, because I could also take the wrong direction as a coder that I'm writing it. And the bad idea is obviously a good thing because you can just close the issue. We don't have to worry about it. We verify that, yeah, it's a stupid idea. We can move on. So, yeah, expect a non-100% success rate. The third point that I want to share is what are the things that this system is good at and what are the things that it is bad at. So I would say it's good at fixing bugs, race conditions, validations, small implementation things. If you break down things into smaller steps, it can follow it through. It can bump your package versions, apply those transformations that are needed in the code. It is very good at backend heavy stuff, like if you need a new controller or some logic or validation or export something from the database, it's very good at it. And I would also add database changes. Like it's good at making database changes, or at least reasonably good. Now the things where I think it's not good is creating new UI stuff. What I mean by new UI stuff is you need a new page. It's simply bad at it. Like Cloud Code is definitely much better at it, but I would say that it's not about the LLM that it is. It's not about the LLM, but it's when you are building UI, you really need to be in front of the UI to look at it. So as you develop some stuff, it creates some stuff, and you need to make small modifications to the UI. This is not good for, let's say, async work compared to the backend work, where it, as long as the code works, it's good. In the UI world, like you really need to sit in front of the UI to make it. So for this, I think that Cloud Code is definitely the best. You can try out to use GitHub Copilot, but I think it is not a good strategy. The other thing is very hard to keep an eye of what is the state of these agents. Like I opened this page, and like some are just completely in the start process, some are, almost there, some need manual testing, some don't. Like I don't have control over it, especially that not all of these things are listed here, which is weird. So yeah, I think that GitHub needs a better UI, or we need a better system overall to keep track of this. The third thing was I got like 200 emails from GitHub last night. That's insane. Like I don't need 200 things in my emails while I'm working. So notification system of GitHub is not, at the current moment, not good at it. I probably need to spend a lot of time to configure it, and my whole team needs to spend time to configure it, because everyone is just spammed by the things that I'm doing. And the last thing is, it is not good at applying additional non-documented changes to the pull request. To give you an example, it is you implement a new page or a new functionality, and then as you are reviewing it, you figure out that, wow, this would be great, but let's add a new functionality that was not documented, not in the issue, never mentioned, but it feels like a good addition. Now, in a traditional coding sense, you would just add it. Like it's simple to add it. But GitHub agents in the background, like they are very bad at it. At least that's my experience. It's better to finish that one pull request with the very specific idea that you had. Open a new issue, document everything, the additions that you want to add, and then trigger it again in the background. Like, don't try to do too much stuff in one pull request. Yeah, I think that's all I had to share. I hope that this was helpful. And yeah, see you next time. Bye.